All right. How's my audio? It looks like it's quite loud. Let me see what I can do here. I meant to adjust this well in advance. Oh, no. Okay, that's better. Maybe too quiet. Still the same. I think that's better. What is going on here? Okay. Test 1, 2. Test 1, 2. Test. That's getting too loud. That's getting too loud. There we go. All right, everybody. Sorry about that. Audio sounds good. It's fine. All right. Hello, everyone. Good morning. It's morning for me. I know that people are watching from all around the world. I have forgotten to turn one of my lights on. I don't know that it actually makes that much of a difference. Let me go ahead and take care of that now. You can see it's a little bit brighter. Maybe it's too bright. I'm going to hit start recording so that everything here is archived to disk, just in case. It's been a while since I did a live stream on YouTube. I'm glad to be here. Having an interesting summer. Oh, let's start off with something fun. So I was recently at Processing Community Day in Copenhagen, where I received this beautiful gift. And I meant to pull up all the information about it. I'll have to do that later, perhaps. This is, and I don't know how well you can see this. I'm looking at my monitor over to my left, an authentic 1950s era Danish train whistle. The actual whistle that train conductors in Denmark, an example of an actual whistle, not a replica. I have this whole beautifully printed and designed information sheet all about the history of this particular whistle. And for the first time ever, I don't know if anyone in the chat was at Processing Community Day Copenhagen, please say hello. But thank you to the organizers of Processing Community Day Copenhagen for this whistle. I hereby begin this first live stream of the coding train in a while on YouTube with my new train whistle. Here we go, everybody. Did I build that up enough for you? Wow. I might have just blown out all of your ears. All I saw was red on my audio monitor. Was that a problem? Thank you for asking about my health. I unfortunately came down with COVID like a few weeks ago now. To be honest, it's taken me a little bit to feel I don't even know that I'm really 100%. I mean, I am testing negative and all the symptoms are mostly gone. I don't know if you can hear it in my voice. There's still a little bit of congestion that I just can't seem to totally shake. Maybe my energy level is a little bit low, but I was just also very inactive for 2 weeks. So I'm slowly getting back into the swing of things. Thank you for asking. Okay, so, but I'm very excited to be here with you. Wucha is on AirPods. Hope you all are fine. If the coding train ruined your hearing, I don't know who you can complain to. I suppose it would be me. All right. So I have a thing. Actually, before I get going, let me just thank today's sponsor of the coding train. These are my friends over at Brilliant. In fact, I was just watching some YouTube videos this morning and Brilliant ads kept popping up and I thought, oh, what is the universe telling me? It's telling me to go live stream and talk about Brilliant, or it just knows that I love Brilliant. And I think that you would too if you like the coding train and you like learning. The topic that I'm going to cover today is a continuation of reviewing my wave function collapse coding challenge, which was a 80-minute coding challenge that I did over several live streams. And one of the fundamental concepts in wave function collapse is the concept of entropy as applied in information theory. And whenever you have some topic like that, from science, from math, from logic, from the world of learning, Is that a world? What I'm trying to say to you is, where do I turn when I want to learn more about a particular subject that I'm interested in making coding examples about? I often turn to Brilliant. In fact, when I come back later in this stream to look at the Brilliant website a little more closely, they have a whole course on information theory. So I'm going to talk about entropy for a little while here, and then we'll revisit the Brilliant course on entropy and see how that is. So anyway, you can sign up for free at brilliant.org/codingtrain. Lots of interactive lessons. I'll show you more about that later. You can sign up for free, and if you want to unlock all of their courses, the first 200 people to do so through that link will receive a 20% off the premium subscription. All right, back to the matter at hand. Beta Hunter asks, how was Denmark? Oh my goodness, I loved it. I love Denmark. I also went to Sweden, which I absolutely loved. And I just had a wonderful time, and I can't wait to go back sometime. So all of you folks from anywhere around the world, invite me. I would love to come. There's so many places I haven't been, I could start listing them all. I'm getting a note from Simon, the intrepid, probably the person with the most knowledge of Coding Train history, catalog, everything. That someone in the chat mentioned that the timer was ticking slowly, meaning the clock in the opening video, it is rendered into a video, that countdown. I wonder if it is inaccurate, not exact time. I'll have to take a look at that, have to investigate. I would love to come to India. And hello from Nigeria. Fox the Bomb asks, how do you take your coffee? I like my coffee with oat milk, either black. I like a single espresso, that's maybe with like one little sugar crystal in it, maybe. If I'm feeling saucy. But mostly I like oat milk. Oat milk. Almond milk is good. Soy milk is fine with. Cashew milk is. I love all the nut milks. They're just, oat isn't a nut, I guess, but. I don't like to talk about food on my video show. I'm making all these references today to a whole podcast network of things that I listen to unnecessarily. I could also do this. Because I've got some stuff coming up. Oh, let's announce something. You're going to have heard it here first. Let's see if I can. Why am I not signed in? Okay, hold on, everybody. Do you mind bearing with me? Oh, this is so sad. Hold on, I have an idea. I really should be more prepared for this kind of stuff. But I have an idea. Talk amongst yourselves. Yes, I'm signed in. Okay. So I have to go to my studio. Hold on, I'm giving you guys the scoop here. I'm announcing something that, well, some of the members who are in the member Discord know about. But I have to pull up a secret private link here that I'm going to make public later today. Let me get that link. And let me bring it over here. Oh, I closed that. I probably shouldn't have closed that. All right, here we go. Yeah, I'm signed out of YouTube. All right, everybody. If you thought you were excited about today's live stream, which is mostly going to be a casual chatting, reviewing a previous coding challenge and talking about things that I missed, I want to try to explain. This is going to be practice because I'm going to have to come back to it in video. I want to try to explain Shannon entropy in more detail, named for Claude Shannon. I don't know how that's going to go. It's probably going to be a bit of a mess. So I'll need you to help me through that. But anyway, live in 2 days, I will be having a guest on Saturday's stream, Dr. Christian Hubicki, who is a professor at Florida State University, runs a robotics lab, is an expert in, I think if I go here to the, there should be a video description here. If I do this, we can find out. Director of the Optimal Robotics Laboratory. His research specializes in bipedal locomotion, specifically optimization methods that apply to both leg robotics and biomechanics. So Christian, Dr. Hubicki does a lot of work with the locomotion of actual physical robots. And as you might be familiar with, I do a lot of coding examples about simulation, not really not simulating robots or even living creatures and their locomotion. Maybe I've touched on it. I've done some kinematics videos. I've done some reinforcement learning / neuroevolution style things. Anyway, Christian's going to be here to teach me about robot controllers. And the first one we're going to look at, hopefully this might be a little bit of a series over the next year, is a PID controller. Something integration derivative. I've watched some YouTube videos about it and I'm learning about it. And he's going to code a simulation in Python. I'll work on it in P5.js. That's happening this Saturday. So this is it's just unlisted right now. I just was like still working on the description and the thumbnail, although I kind of like it. See if anybody can catch the Easter egg in this thumbnail right here with these numbers. So I'd love for you to tune into this. I'm really excited about it. We'll see how that goes. Okay. Now, back to today. So I'm going to make a list here of things that I'm going to cover. So first, I want to follow up about the horizontal directional drilling. Let's write that down. Then we're going to look at wave function collapse. And there's a whole bunch of things that I want to look at. So I'm going to look at the passenger showcase. I am going to look at corrections, and I'm going to look at YouTube comments that people have made with some corrections or questions. I am going to look at a corrections and next steps document. And then anything else that comes up, I will add here to my list. Pete the Paperboat says, I made a ball balancing robot with a PID controller. They're very cool. So did you make a physical, like an actual robot or a simulation? I guess when somebody says I made a robot, they're generally saying they made a physical robot. It's just for me, like my mind goes to simulation pretty instantly. All right. I'm trying to think of what else that I want to cover. The numbers are purple in hex. That's a good guess. I didn't consider that, but let's take a look. Let's do background. Let's go back to this. Did I close that window? I don't remember what the numbers are. 762687. That's a really cool guess. I can use that for a future. This lovely purple. So I didn't think of that, but we do get this lovely purple from that hex code. Anybody else? I would love to give a prize for somebody who gets it, but I don't know how to find the right person who got it first or whatever. That seems scary and problematic. All right, let's see. Let's talk about, let me go to the first thing on my list here. So first of all, in case you haven't seen it, and there's a lot more to say and to come about the website, this is the new Coding Train website. It's coming along. I really have to thank, there's too many people for me to thank, but just to name a couple, Fun Planet and KFon22 have been, the amount of times I've been recorded saying, oops, that's a good one. It could be. I haven't done an accounting of that. I would love for somebody to do that. Have been porting so much of the content from the old website over to the new website. Just the sort of volunteer effort from the community has been amazing. Let's see who else. I shout out a couple names that jumped to my mind, but I think if I go here into the website's GitHub and I go under Insights and I go to Contributors, we can see here. These are all of these folks here that I really just need to thank and for contributing to the website. And there's a long list because one of the exciting new things about the website is the passenger showcase. So where is that? Here it is. So here is Chris Sears' Bezier Arch synthwave animation based off of the Coding Train Bezier curve video. And if I go to any of the challenges, for example, come on, website, you can do it. What's happening? Twitter was down for a little while. Is the internet broken today? I see, by the way, a Simon is typing ... out of the corner of my eye, and I just have to wonder. So there is, Jasper is asking about I hesitate to show this because it's still in progress, but on the About page, I don't know why I can't get any of the pages on the website to load. Am I clicking incorrectly? Have I lost the ability to use the internet? What is going on? The number of minutes recorded. People are doing really great guesses about the 762-687. That is not it. Number of minutes recorded on the coding train. The route challenge is broken. What is going on? How could this be? What happened? Where's my technical difficulties slide and music? This is insane. Is the internet working? I mean, obviously I'm streaming. You're seeing me. I have a green light over there for my connection. Did Netlify go down? So interestingly enough, this laptop is connected through a mesh Wi-Fi network, and my streaming PC is hardwired into the ground, basically. And people are saying it works. I think there's something wrong with the internet here on this particular laptop. Okay, the editor shows up. There we go. All right, that was a temporary little glitch there. So here I am on the challenges page, and I'm going to go to the most recent challenge, horizontal directional drilling, which was a collaboration with Practical Engineering. So if you haven't checked out the Practical Engineering video about this topic, please do. I just kind of, as every opportunity I have, I like to alert people to the new website. So if you are looking for all the metadata associated with a coding train video, of course I expect that most people are going to find the videos on YouTube and watch them on YouTube. The reason for the website is to make finding the source code that goes with the video more easily. Any reference links that are in the video are linked here with the description, as well as other related videos. In particular, I can just click over and we can see, look at this, sponsored by Brilliant. See, I love this. This is just it's like the universe knows. I've clicked to a YouTube video that's going to show me an ad before I could play it. And it's as if I'm playing the ad that's the actual, and we got somebody join us. Remember, so much is happening. I don't want to skip the ad. I feel like I can't skip the Brilliant ad. I got to let it play all the way through. This is amazing. It's interesting that I'm not signed in also. And I don't know where it's pulling, decide to show that ad and show all these recommendations, but let's go here. So this is the amazing video from Practical Engineering. Yes, I'm going to be talking about wave function collapse. I'm just kind of covering, I'm being too long-winded about this, but I just kind of recapping some recent things that are happening on the coding train. So check out the Practical Engineering video. By the way, I was going to say, all these people have come to my channel now saying, came here for Practical Engineering. And, I've seen, maybe that's not people should leave comments with a little bit more substance to them. I don't want to flood Practical Engineering's channel with spam, but I just wanted to say, if you found this video from the coding train, maybe send Grady a little note just saying hello there. He might appreciate that. Okay. Okay. Yes, Simon. Thanks for that information. I got to come back to that. All right. So I'm closing this out. So the reason why I'm showing this to you is, when in the coding challenge, I have this very, very, very basic simulation of toggling the bias of a horizontal directional drilling machine to carve out a path through the earth. With no obstacles, with no sensing, with no particular goal. And one of the prompts from the video, that challenge was to ask people to submit and create their own variations of this. And boy, were my expectations wildly exceeded. So if I go back to the challenge page on the website, and that's over here, and I go to the expanded game, this is a GitHub repository and I guess I should start protecting my main branches, that has a little bit of documentation here in the README, and you can currently see now what the current version of the game looks like. It's got a much more elaborate interface where you can reverse the drill, start and stop. There's obstacles. There's this fog of uncertainty parameter, which makes it so that you can't actually see the obstacles, but you can kind of get this view of clues as to where those obstacles might be. There's a target that you have to get to. Whoa, I just kind of twisted my ankle there, weirdly. By the way, I always like to show people this is the full view of everything that's in my room here. That's why I just kind of twisted my ankle like that for no particular reason. So let's play this game. Lots of people have contributed to this. I could head over to the insights as well and go to contributors and see all of these different names. So thank you to everyone who's participated. A special shout out to Sergey, who is a researcher in applied mathematics and has really been putting in a lot of effort into this game and simulation. And I think even did something which maybe I should do for more of my coding train work, which is added a citation link to cite this particular simulation and code example in an academic paper. So we'll see. Maybe we can get the coding train cited in more academic papers. That would be a fun thing. Once with our collaboration with a real life robot scientist, maybe that's the future of the coding train here. I mean, I do teach at a university as my day job, but I don't consider myself an academic per se. I'm not an academic. I just play one on YouTube. Okay. So let's actually go ahead and play it now. I'm going to click over to it. The interface, as you can see, is much more elaborate. Let's pause. So one thing that's really wild, first of all, I love, is that there's a whole animated drilling machine, which is just, people are still trying to guess 762, 687. Nobody's gotten it. By the way, you're off. Like the direction that people are going, it's not a data, an amount of something related to the coding train. I'll just tell you they're off in that. That's not that would have been, that's clever. I probably should have thought of that, but it's not what it is. All right. So first of all, we love this animation. Let's see. Can I pull back a little bit here? Pull back doesn't seem to be working, but maybe I didn't go far enough. I can toggle the bias. I can uncheck this fog of uncertainty. So without it, I can see the geological layers and the actual obstacles. Let's put that back on. Visual instructions. Oh, that just takes me to this image. Oh, I think I might have gone away there. Okay, great. I get to start again. By the way, there's also by using random seed, there's this nice persistent link to this level. So you can see here in the query string, we now have, so maybe we should see, is it a random seed? It's not this, but this would be fun. 762, 687. Let's play that one. All right, this looks like a good one. I'm going to see if I can reach the goal. I'll stop talking for a second. I don't know what's just popping up there, if that's a bug or that's supposed to be happening. All right, we can see that my path, I'm not going to make it, am I? Nope. Now, and you can see you get this whole kind of score, like a reward for maybe the amount of time, the distance you have, the drill length. I haven't actually done a deep dive into what the score has been. This is wild. Can I pull back? No. So let's refresh. We'll try it again. All right. I think I'm going to be able to get it. This one doesn't look like that hard a level. You just need to kind of toggle back and forth to kind of go straight here. What is flashing there? Can anybody tell me? All right, this should get me there. Oh, so close to this should get me there. Oh, come on, bend back. Oh, okay. Oops, nope. Let's try this again. I'm going to get this one. I need some dramatic music playing. I need my dramatic music tracks at the ready. Okay, come on. I really got to sneak around this one as close as possible. I think this should do it. Come on, bend! Oh! The pop-up happens when a checkpoint is added. The pullback. Oh, there's checkpoints for pullback points. Okay. Calculator turned upside down, says Chris Sears. No, it's a good guess. All right. I feel like you know me, I'm like, I have a problem when I'm streaming and like I refuse to just move on to the next thing, even though when I clearly should, as I'm super stubborn. But let's see here. I mean, it's possible that a given map is actually impossible. I want to try to stay as close to this as possible. Oh, no. It's all about bending right around. That was like, oh, no. Oh. I'm going to get it. I see the path now. This is harder than I thought it would be. Or maybe I just picked a really hard level. See, I once again, I need to be bending right. That's the key. I also should pause and pull back. Keyboard control might help me here. I think there are keyboard controls. There we go. There we go. That's going to get it, right? Oh, I was so close. Pause. Are you all, try going down further so you have more room to turn around. Oh, that makes sense. Good tip, everybody. I don't know why I was trying to that makes sense. Yeah, now I see. I was kind of taking the wrong approach. I was trying to get as tight a turn as possible, but actually, oh yeah, this is so much easier now. There we go. Come on. No! No, that was, oh man, my pixel color detection is. By the way, I could also take the randomness out. The randomness is just a little bit of noise in there that doesn't make the turning as perfect. But, all right, this is clearly the way to do it. Whoa, don't hit that obstacle. Close. Let's go all the way down. So this will give me a lot of room to turn. There we go. We did it, everybody! Yes, train whistle. Where did I put my new special train whistle? I put it away. Oh, no, it's fine. There's too many steps to pull this back out. All right, everybody. Okay, look at my score. Now we need like a share button so we can kind of like Wordle tweet it out. All right, we made it. Anyway, so I'm really thrilled about this. Thank you for everybody who contributed. There's still plenty more could be done. I think a lot of work could probably be done on this to think about how this could be adapted for mobile. I believe it does work on mobile, but thinking about, I think, the interaction design as well as the aspect ratio of the sort of scene that you're looking at, there's probably a lot of improvements that could be made there. All right. Wow, it's 10:35. By the way, I have a hard out at noon today. So this stream is going to end like promptly at 11:55. Like no ifs, ands, or buts. And not one of those where I say I have to end and then I go an extra half an hour. So really stopping. All right. Okay. My back. I haven't exercised because I'm having COVID. My whole body kind of just aches and is weak. It's also really hot. So it's kind of too hot to go running, especially if I have been out of practice. So I got to figure this out here. Got to get some more exercise in. I have no AC, by the way, in the studio. It's getting quite warm in here. So I might need to start the opposite problem of the winter when it gets too cold in here. But I might need to get a fan. We'll see. All right. Let's turn our attention back to wave function collapse. Yes, Christoph B. Amazon link in the description. So apologies for that. So first of all, I mean, I don't know if I should just be addressing random things here, but that's what the live streaming is for, to chat with the audience. So I'll address this. At one point, I had a Coding Train affiliate shop with Amazon. So I would link to various books and different things from videos. And, I would earn like some small, I think it's 6% commission on purchases made through that link. At some point, Amazon canceled my affiliate. I violated some guidelines, and maybe I put a link on a place that wasn't approved. I have no idea what I did. I sent some support emails and whatever, appealed it, never rejected, no response, etc. So I gave up. First of all, I'm not, to be honest, not a fan of Amazon. I mean, who is? I don't know. So I'm kind of like, maybe this is a sign from the universe telling me stop linking to Amazon. But I would like to be able to share, especially like books, I think, that I use for my own research and preparation. I have 2 books that I've written that I could share links to. So I was thinking of actually setting up a store, sort of storefront through, oh, this is not it. It's a bookshop. It's bookshop.org, I think. Yeah. Is this it? So this is a online bookstore that supports local bookstores. So I think I can create an account. I just haven't had time to do this. Oh, look, and we have a new U.S. Poet Laureate. You should all listen to the Commonplace Poetry Podcast. Shout out to friend of Coding Train, Commonplace Poetry Podcast. I believe this Poet Laureate was a guest at one point on that podcast. Tell him the Coding Train sent you. Anyway, so I would love someone to remind me about this because I keep meaning to set it up and then replace all the Amazon links with Bookshop. So David suggests a treadmill under my standing desk. And Alexander says, no ifs, you say? How about a switch? All right, that was a good one. All right. Let's see. Actually, just out of curiosity, can you even get the Nature of Code book here? Looks like you can. So that's good. I can link through here. Wonderful. The irony here, of course, is that this book is printed. The Nature of Code is, the print version is Amazon Kindle Direct, basically. So, which wasn't what I originally set out to do. I used a company called CreateSpace at the time, which was a print-on-demand service for self-published books. But Amazon acquired them. So actually, this is a great question. And I was thinking of reaching out to some publishing contacts. I am, I'm having to eat my words here because all I do is say that I'm doing this, and progress has been made. But I think I probably should take a couple weeks off from Coding Train video work and only work on the Nature of Code book. I don't know if you would all accept that from me. I mean, sometimes I'm gone for weeks at a time just for personal stuff and travel, and I got COVID, and I have anxiety issues. There's all sorts of reasons why I disappear and don't make a video for a month. But what I'm saying is I'm really having trouble. I think it's not really like a motivation thing, because internally I feel very motivated to work on the Nature of Code, but it's a procrastination issue. Like, I'll do anything to avoid it. So I wonder if I should really just close everything else out and just for 2 weeks only work on this. One idea I have was using Twitch streams as a mechanism for just streaming me working on the book. It would be more of a silent stream. I don't know how distracting that would be, how productive it would be, but I'm thinking of doing that next week. All right. Nobody's gotten this yet. I'm not gonna reveal it because you know what? You know why I think nobody's gotten this yet? Is because you have to be an old person. I'll have to explain. I'm realizing you Gen Z folks, you're not thinking on these terms. I don't want to give too much away there. But if you write a switch statement in the stream, I don't get the joke about the switch statement. Okay. All right. Twitch streams are better. Okay. All right. Thanks for the feedback, everybody. All right. I've got to move on to wave function collapse here. All right. So let's take a look at, I think I have it featured here, so I can just get right to it. All right. So first of all, if you haven't watched this video yet, I would love for you. I mean, you could go leave right now and watch it. I mean, I would have no complaints if you did that. In fact, that might be a better use of your time. It's quite long. I would love to hear your feedback, anecdotally, and also based on the sort of YouTube numbers for it. Part of me was thinking, is this a mistake? Should I have made a just 10-minute explanation of the algorithm, summary of it, walkthrough of the code, print, done, script it, edit it, publish it to YouTube. This is instead my sort of Coding Train style of an edited version of me building the whole project over hours and hours and hours with little animations and hopefully some extra things to help you understand, extra references, but also little animated jokes and funny moments, some sound effects and that kind of thing. So, but it seems like if I have a big project to tackle like this is a way of doing it and it has value for the audience. So far, so good. If you are looking for the source code for it, I'll just click on it right here. This is the P5 web editor. I'm going to dig into the source code a bit deeper and look at what's currently in the GitHub repository, but we can see the algorithm here generating this PCB board-like pattern. If you want to understand what it's doing, that whole video will hopefully explain it to you. I really encourage you to take a look at these references, different references of links of things. If you're watching the video and something I've referred to is not part of the list, file an issue on the Coding Train website. You can leave a YouTube comment, but those I sometimes miss. So file an issue on the Coding Train website, send me a tweet. You can actually add it yourself through a pull request. So I love your contributions. I also just want to highlight this tab, which is, I've made references to many projects, artworks, games that in the video, so you can find all of those here, providing credits. Again, if I missed something, please let me know so I can add it. This, by the way, this is 80 minutes long and is the edited version of what I did over 3 live streams. So if you, I was going to say if you are insane, but I don't, this is not for the faint of heart. But if you might be interested, so Ketan Balakar got it. Although it's different, it's put in a different way. So Ketan, I don't think anybody, oh no, Daniel Franklin got it first. Daniel Franklin, if we can authenticate you, I will send you a sticker pack, a Coding Train sticker pack. Let me write this down. YouTube, Daniel Franklin. And somebody in the chat got it before, please let me know. But I would love to send Daniel Franklin, and it was just 2 messages later. Ketan, I'm going to write down Ketan. Let's see if I can send Ketan a sticker pack also. Ketan Balakar. These are YouTube names. I'm writing them down. I will review the chat. I have to figure out how to authenticate you as a real life person. But Mason Sickler got it. Okay, hold on. Let's scroll back in the chat. I don't see it. This chat is being logged, so I'll go back and review it. Mason Sickler. Okay, so I'm going to write down Mason Sickler. Yes, if you, on the keypad, if you type out, is the audio, no, my audio is going. On the keypad, if you type it out, you'll get robots. All right, so not for the faint of heart. Not for the faint of heart. This is about 9 hours of me doing everything. So if you were ever curious about how a Coding Train coding challenge gets edited into a video and you want to see the raw material, it's all there for you. There's nothing hidden. So the reality of everything I went through to produce that video is all there in these 3 live streams. Mason Sickler. Looks like Mason got it first. Chris Sears also confirms that in the Coding Train member Discord. By the way, we got a new member during this live stream. Pedro. Oh, so here's thank you. So Pedro brings up an excellent point. Right, the code for the Rubik's Cube challenge is not accessible through the link in the video. Could you update that? So this is a major issue, and I haven't been able to go and update. So let's go to the Rubik's Cube challenge and show you what's happening. So Coding Train Rubik's Cube. Part 1. I'm going to go to this one. Let's see if we get an ad. No, no more ad for Brilliant. Hack the Planet. Okay, let's skip this. I try to usually be logged in to YouTube because I have YouTube Premium so that I don't show ads. But all right, so this is going to happen to you a lot here. The YouTube description also has a lot of the metadata associated with any given video. Less, and I'm trying to improve that. If I click here, it's going to take me to page not found because there is no page. one, this is the wrong URL, but even if there were, this would still take me to page not found, but this coding challenge has not been ported to the new website yet. So if I go here under challenges and I start to search and I kind of page through, actually finding a given challenge is also a little tricky that I want to work on. But if I page through all the challenges, I won't find it. So I just want to see if that 404 page, oh, you know what's missing from here? So here's another thing I just found. This 404 page needs to link to the old website. So I'm going to write this down. 404 page, link to old website. So the old website is not gone. You can still find it. And it is, I'm going to give you the URL for it right now. codingtrain.github.io/website archive. So it's this URL. This is no longer being maintained. Don't file any bugs or issues. Something's broken on this website. Not going to get fixed. But if you're looking for old content that seems to be missing from the new website or something that was there before, you can still find it. I'm going to go to coding challenges. I'm going to go to Rubik's Cube. I'm going to go to the challenge. And in theory, the code should be like, I know I did this in processing, so I'm going to click there. The code should be here. So here you found, now the other thing I'll say is in all of this new reorganization, there is a new GitHub repo. I think it's this. There is also this GitHub repo, which just has all the code for all the coding challenges. So if you don't want to like be navigating through all the different websites links, you can also just come to here and find Rubik's Cube 1. You can find the code for it here. You can, Alexander said, I am doing some redirects to the old website. I didn't want to automate this because I really just want to like do away with the old website. I don't want people having to go there. So I think I have a little bit of a mental block with like, I don't want to put in the effort to like redirect everything. The point is to have the new website working and to go and update all my YouTube descriptions. If you would like to help with this, what you can do is, I'm going to go to thecodingtrain.com. I'm going to go under guides, and I'm going to look at this maintaining the website guide. So if I click on this guide will show you how to add a page to the Coding Train website for a video that doesn't exist. And you'll see that if I go to let's see if we can go to the repo. I'm sure there is a link to it at some point here. Maybe this is an issue that it's not easily findable. Just looking. Yeah. Well, I know where it is. Is there a link to the GitHub? Like right about, maybe under the about. There's a link to GitHub here. Just curious where. Oh, probably in the. So I probably should, maybe in the footer. I mean, it goes to the Coding Train GitHub, but actually have a link to very specifically to the Coding Train website. It's not a big deal. It's the first pinned repo. So I'm overthinking this. All right. If I go under pull requests, you will see here that people are opening pull requests. This one's from KFon22. Who has opened a pull request for the Chaos Game Coding Challenge. And we can see, so you can participate in this. It's at this point kind of a volunteer effort with some maintainers who work on Coding Train projects helping along with it. So, but I will say the site uses Gatsby. And if I go here under redirects, like I am specifically redirecting a few things. So if there is like some of the most visited pages on the old site, I'm like redirecting them to the correct website. So if you want to pull request any redirects to this JSON file, those will also work. That would also be welcome. And yes, so this has been, I've talked about this to death on other streams about the website. I don't know which specific aspect Chris Manning is referring to. This could be automated. It could be automated. But the whole point of me doing this is that the old website has out-of-date links, incomplete information. So I don't want to automate bringing all the content over and just have a totally broken website. So we're doing it page by page at a time so that everything is corrected and built out. It's much more important to me. I'd rather have something totally missing than there but broken. And if you go through the site maintenance guide, we've automated a lot of the steps for you. That there's a starting template. We've reformatted it in the JSON format, but it does require a manual step to review all the content and correct it and update it to work on the new website. But maybe you're referring to automating all the redirects, which I also could do. But again, if somebody wants to just take that on, great. But I'm trying to prioritize the things that are most important to me. My goal here is to have this website really finished and built out with all the content by the start of school in the fall, because that tends to be when teachers and students and people around the world are using the resources on the website most. Okay, thank you for the screenshot. Also got a screenshot of the chat of Mason Sickler. Okay. So Tomer is asking such a good question, and I'm got to move on here. To looking at the passenger showcase. But do you look at passengers code only in P5JS? No! The answer to that is definitely 100% distinctly a no. The whole point of what I'm doing is, I love P5. You want to use P5? Great. There's a lot of reasons why you probably do, and they're good reasons. But the point of what I'm doing is to share my passion for teaching code and trying code and struggling through code with you, and for you to share what you make back with me. And when you do apply something that I've tried in a different language, in a different format, in a different way, that's the most exciting thing to me. So please port it to Unity, Python, C++, do it by hand. You want to make a wave function collapse quilt where you execute the algorithm by hand and sell it on Etsy. You don't have to sell it, but I would buy it. I would buy that instantly, insta-buy, insta-purchase. Anybody wants to make a wave func quilt, physical thing, please go for it. Share it with me. That's I would love that. Rodoc is here. Rodoc, perfect timing. Hi, Rodoc. Thank you for your membership. I didn't even realize. Yeah, and I do want to start doing more challenges in other languages as well. But, the list of things that I would like to do on this channel is very long. And the reality is I get to 1% of it. All right, so let's move on, because I've spent too much time just kind of rambling away here. I'll remind you that even though there's not a lot of code happening today, although I do have some intention of writing some code. We'll see if we'll get to it. Saturday, I'll be live streaming on Saturday and doing a coding challenge. So come back on Saturday for my robot controllers with guest Dr. Christian Ubicki. Okay, let's close out a bunch of these tabs. We've covered the horizontal directional drilling. I'm going to come back to Brilliant in a second. I talked about Bookshop. This is the Rubik's Cube challenge. Look, let's just compare. Look at this gray. What year was this? 2019. I wonder though, I think in my old studio, the lighting was such that the gray didn't show up as much as the lighting in here. Obviously I do have more gray hair. A little self-conscious because I've been recently getting comments. I used to only get comments of wait, I just found out how old you are. You look like you're 27. And now I've recently gotten comments oh, you look like you've aged a lot in your videos, which it's been a rough couple of years for everybody. Not even barely for me compared to, I think, what other people have been going through. All right. All right, now back to wave function collapse. Let's start looking at the passenger showcase. Let's see, so we have a little bit of an issue. We're having a little bit of an issue with the website, which somebody might actually be able to help with if you have experience with Gatsby and Netlify. Anybody here is a Gatsby/deployment to Netlify expert? Please get in touch. Are you not 27? No. By the way, my birthday's coming up. Just putting that out there in the universe. Is it Bastille Day today? Nothing wrong with. I agree. By the way, I have a very youthful demeanor. I'm feeling my age. COVID really got me. I've triple. I had my booster. Had everything. I probably had the variant. I'm sure it was Omicron, which I know has been milder, but I had a rough time with it, and I have not recovered. So fully recovered. I have recovered, but I'm hoping it will slowly each week. I'll get even better. I feel like cloudy in the head, but I mean, I also am just like, I'm so neurotic about things that I think I might be overly like obsessively like analyzing every slight feeling anywhere as like a possible symptom. So, all right. Now, so Rodek, your contribution is not showing up here right now, but I do want to show it. So somebody remind me if I haven't. Natcha Code says help with Netlify. So I will, my birthday's not for a couple weeks. It's not today. So, all right. So, but let's start going through these. So one, by the way, if you're not a fan or viewer of Sable Rafe and Creative Code News and his Twitch channel, I'm really inspired by what he does with reviewing projects that are made by his community. I do actually think his methodology is better in the sense that there is a theme like flowers for the week, whereas these projects shared by the community are tied to a particular algorithm or video, but it works for the coding train, and it is nice to be able to see a tutorial and see what people have done with that. So I do think there's value in both, but you should definitely check that out. I mean, he does a wonderful job reviewing doing Twitch streams weekly where he reviews submissions from the community, and I would like to start doing more of the same. So let's get right to it. Number 1, wave function collapse in Python with backtracking. So let's take a look at this. We're going to go over, and we can see here that this looks like a port of the wave function collapse algorithm in Python. And we can see, oh, look at this. Now, dare I try to run this? Look at these. Ooh, I love that there's a Mondrian one. Look at these. These are fantastic. So this is and by the way, I want to address this mistake that I made. I mean, what's a mistake? You know, there's a lot of artistic license here. Like, why is this a mistake versus not a mistake? But it's a mistake in the sense that if I were trying to reproduce the precise, and Natcha, yeah, is it Natcha Code, let me know if it's on the page or not. If it's on the page, I'm going to get to it. If it's not, I need people to alert me to be able to look at it during the stream. The original sort of design for this would be to not have these individual, I'm trying to not step out of frame here and cut myself off, but not have these little individual squares or these really thin sort of like rectangles. So that's a mistake that I want to address. I really love this one. Like, this is really cool looking as well. I mean, all of these are great. I love this sort of like maze generator-like thing. So these are fantastic. So let's try it. That's what today is for. Let's try seeing if I can run this. Let's learn how to do it because I don't do a lot of Python. So I'm going to open up. I'm going to go here, and let's go back. Let's follow these instructions. So let me clone this repo. And so now I've got the repo. I can go into it. Let's see here. Let's follow these. So this is, these instructions here really have nothing to do with this particular project. This has to do with creating a virtual environment. So I don't know if you've ever programmed in Python. I have a video about this. Hopefully it's not too out of date if you're looking for it, where I go through this in a bit more detail. But the Python settings and configuration and dependencies and version that you have on your computer can get tangled up in total spaghetti if you're just constantly like updating and installing things. And different projects will not be compatible with certain versions and certain dependencies. And it can be a total mess if you just use like one Python environment, the sort of like global environment of Python on your computer. Actually, if you're using online notebooks, like a Colab notebook, that's in essence, each notebook is its own kind of virtual environment. But the idea here is to set up sort of a sandbox, a blank slate version of Python that's activated for this particular project so I can have the right version and all the dependencies, etc. So let's see if I can get this going. So I think, though, I want to be what I would suggest doing is this is actually my own name of the virtual environment. So I'm going to call this WFC. So I want to create a virtual environment called Wave Function Collapse. Oh, and you know what? I've got to say Python 3 because this command venv is the command for Python version 3, which I have. So that created that virtual environment, and then I need to run this activation script, essentially, which is now in the folder Wave Function Collapse, which now I can see here, I've activated that virtual environment. So anything I do right now, if I type Python, Python dash, oh, what happened? Yeah, I guess I need dash V is something else. Dash version will see the version of Python I'm running for this particular virtual environment, right? Because if I open up a new tab and type Python version, that's the global Python on my computer, and I have Python 3 installed under Python 3. So I created a virtual environment, Python environment, with Python 3. Now let's go back. And I need to install all the requirements, the dependencies for this project. NumPy, gotta love NumPy. OpenCV, now this is interesting. Like, what are these dependencies being used for? Like, what in OpenCV is for this Wave Function Collapse project? That's really interesting. Now, let's just try running Python simple py. Building a tile sheet, collapsing, building the image, and we should see, there it is. 11 a.m. Look at that one I made. Let's try doing another one. Now, all their arguments where I can make it like higher resolution and stuff, I'll have to look through. That would be a really cool thing. I really like this one, so let's run this one. Sheet 40 by 40, tile 7 by 7. So let's go look in the code. And I'll also be curious, like, where did these designs come from? Like, there are sort of the canonical example Wave Function Collapse tiles that a lot of different examples and repositories use. Also, I'm forgetting that I wanted to start with talking about something, 2007 PhD dissertation called Model Synthesis, which I think is I neglected to reference specifically in my video. But that's obviously a really key reference to the origins of the Wave Function Collapse algorithm. So let's look at abstract.py. So yeah, so it looks like I could just do, I'm just curious, what if I change this to 80 by 80? It still says, still said 40 by 40. So I'm not so sure. What's going on here? Fine, you can install that. I don't know if the log was just logging, hard coding 40 by 40, but let's go to, which one did I just do? What should the file name be? Although I guess I can look at date modified, abstract. Oh, so that didn't work. Something about me changing it to 80 by 80 caused it to fail. Let's go back. (40 by 40, tile 7 by 7. Let's see, take a look now. Yeah. So I'm not sure, I mean, I have to dive deeper into the code, but that's something that I would want to be able to, and maybe it would make sense for me to say something like, and I know you might not be able to see it, Python abstract, and then have, like dimension be 80 or something. I don't know. I don't know what the proper way to format the arguments, that would be kind of cool. Zachary, that's a great question. I'm going to keep going. I wish I could I need to do a better job of collecting people's questions so I can answer them at the end. But the short answer is Zachary about, do I have online lectures from NYU? I mean, the short answer is yes. They're indistinguishable from a lot of my videos because I release them as like public-facing videos. Okay, so I want to look a little more at the code just to sort of see like if we could learn anything from it. But we can see the data structures look somewhat similar. Tiles data, left side data, right side data. Load tiles, the rotation is here. So this looks like a lot of similar kind of code to what I implemented, probably with some optimization and improvements, I would imagine. I love that there's this function about defining the neighbors, updating the neighbors, find lowest entropy. Amazing. So I love seeing this. Great work. Great work. Okay, let's move on. Thank you, DeShrike, for submitting this. Let's take a look at wave function collapse. And I haven't looked at these. I mean, I've glanced at them, but I haven't looked at all these. Wave function collapse by Asanka Sovis. So here we have a repo. So first of all, I always love to see a nice animated GIF in a repo's README to give me a quick view of what's going on. There is a blog post. Amazing that there's a blog post. Oh, fantastic documentation. Explaining the set of tiles. These are the ones that I used. Defining the rules. Tiles as a class. So this is being done now in, looks like it's being done, ported in processing. Small comment, this is a very nitpicky comment, but I cannot help myself. The convention would be to capitalize the names for a class. Lowercase for variable names, capital for class names. And I would recommend doing that purely for your own sort of sanity and documentation. Doesn't affect the functionality, but you'll notice here, P image is capitalized. So that's one little nitpicky comment. We can see the tile set, creating a new tile object with the image. This must be defining the sides of the tile. I'm just trying to understand what the second index value is. 0, 2. Oh no, these are the valid neighbors. These are the valid neighbors. The index of the valid neighbors. So this is done looks like it's done more in the sort of first way that I did it. Function that returns all the tiles. That's great. I love this documentation where it's all explained. This is fantastic work. One of the awkward things about working in Java. Oh, Asanka is there in the chat. Oh, yay. I'm so glad that the whole point of this is I love that you're here in the chat. Wonderful. This is one I'm very impressed with that you did this, because this is one of the real heartaches of working in Java is to have to deal with these very long-winded, statically typed, or I don't know if that's the right term, but array lists. Arrays in JavaScript are just so flexible and easy to mess with. Conclusion. I'm intrigued why you referencing Perlin noise here. I'm obviously not reading this in detail. And then thank you. So thank you but this is amazing. I want to share this. Remember to share this through the Coding Train Twitter as well. So really great work. And I would love to see. I just really appreciate this level of documentation. All right. Coding adventure, that's really the term. That's Sebastian Lagg's term. So, but coding challenge, I guess, is what I'm stuck with. All right. Stefano Silvreschi, aperiodic tiling. A lot of people made okay. Be warned. So first of all, excellent documentation in the comments here. It may take a while to find the right tiling if you're using a generic seed. When it manages to complete the grid, the output will always be an aperiodic tiling. So a lot of people in the comments referenced Wang or Wang tiles. So I need to do some more research. Yes, here it is. So I definitely would like to read this paper, and maybe this is something for a future coding challenge. Am I doing something totally redundant if I have this as the topic of a future coding challenge, or might I take other approaches to this concept of Wang or Wang titles? I'm not sure the proper pronunciation. By the way, I already can hear my voice going, and that's the sort of remnants of COVID. I've just been congested, sort of sore throat, just has not totally gone away. Okay, and let's run this. Oh, this is amazing. This is absolutely beautiful, and I wish I knew more about this to be able to explain and discuss it further. So first of all, that didn't seem to take a long time to find the seed at all. And I wonder if it's, I see. Interesting. So there is a hard-coded seed in there. So for 600 by 600 dimension equals 20, like we could try this seed. Cool. I'm actually also curious to up the dimensions to see what happens. There's a real joy in just watching these go. It's almost, you can sort of imagine this crew of little tiny robots inside the computer trying to assemble this pattern. So, I always find this to be an interesting question. Is the sort of beauty of the algorithm in watching it execute, animate, or is it in the final result? And these are not mutually exclusive, and these are not yes or no questions. But I think it's a really interesting discussion to be had. And I certainly find both, in the case of implementations of wave function collapse, to be quite... Stefano is there too. I should try one less. 1777. I would love to hear from you, Stefano, more about implement the actual rules for aperiodic tiling. What did you mean by that? Is this kind of a simulation of sort of the idea of aperiodic tiling as visualized through wave function collapse, but there's a whole way of creating this pattern without using wave function collapse that uses another set of rules? And do you think this would make sense for me to tackle as a coding challenge video? Anyway, this is wonderful. I'm always curious to look at, I don't know to what extent, this looks quite similar to, so look at this. So we can see this is really using my code base, which is great. I mean, that's the whole idea of this. And I'm intrigued to see that that these are done. Let's look. One thing that I don't love about the P5 web editor is it doesn't let me preview these images. So if I wanted to, I have to just download the sketch. But I'm curious to see what these tiles actually look like. Just stop for a second and imagine. I guess we can see because we can see the outline of the grid here, but it's almost like you imagine the tiles to be the single squares that are rotated, and we're actually laying them out in this rotated fashion, but we're not. And actually, the tiles are... Oh, why aren't these not previewing? That was weird. Okay, I'm at a loss here. Huh. Why did they not download? Anyway, I suppose you can imagine. That's so strange. I'm not going to worry. I don't know if that's a bug in the P5 web editor or something happening. The wave function collapse eventually finds an aperiodic tiling with those 11 tiles. There are actual rules to get a tiling with the Wang tiles. Got it. Okay, thank you for that comment. This is so fun. Okay, wonderful. By the way, there's also, I think, a really great, I think Rune Madsen and his programming design systems has, I thought Rune for programming design systems has a nice article about symmetry. Might have seen it somewhere else. Maybe it's somewhere else and not in the book yet. But this is a wonderful resource if you haven't found it, if you haven't seen it before. Okay, moving on. I guess so I'm gonna, I really thought I was gonna be able to do a lot more during this live stream, and I do want to look at entropy and brilliant, but let's keep going. Let's see if I can get through these before I do that. Okay. So this is Guericci's wave function collapse. We can see it's directly a fork. And the change log here is there's a custom pattern. So I wonder if, I'm just curious to see what was changed here. Circuit inspired. So there's a new pattern here with a new set of rules that are noted with a different notation with this underscore. All right, so I think I need to clone this repo to sort of see, oh, wow. Look at these, this is a dream. So I'm curious, I don't know if you're in the chat, whoever, Glitchy. But if you are in the chat, please say hello, because I'm really curious, like, where did you design these tiles yourself? And I need to find it, whoops. So let's clone this. I'm going to just make a directory called Showcase. I should have put the other one in it. Let's grab this repo. Let's run a server and see what we've got here. Wow. This is beautiful. So look at this pattern from these tiles. It's very creative. What I find so, I mean, it's like a circuit design, but this sort of alpha blending and gradient of these patterns, and it's just really beautiful and unique. If we look at the tiles, let's look at these tiles. This one is circuit inspired. Look, so first of all, there's a lot more tiles. This has 20 tiles. And we can sort of see, like, there are some very basic ones. Like, that must connect off of this on the top. We can sort of extrapolate what the rules might be. But that's just wonderful. I'm always curious. We can see that with all of these tiles and permutations, it runs rather slow. I'm just curious, like, how far we can maybe push it. Oops. Oops, wrong one. Let's take a look at the code here. And let's try 30. Yeah, let's try 30. Just curious. So now you can see it's running much slower. So this is really a lot. One thing I didn't pay attention to at all in wave function collapse is optimizing to get the thing to run faster. And if you dig into the algorithm deeper and look at a lot of people's implementations, that's what a lot of work goes into. But I do believe that there's the potential to run this quite a bit faster. I would imagine even just like the processing ports run faster just from sort of running in JavaScript in the browser with no kind of workers or WebAssembly or WebGL or optimization generally tends to run pretty slow. But let's let this generate. I'm also amazed at how well this is doing with not getting stuck. Again, there's no, I missed quite a few things about recursion and backtracking and various things to help the algorithm not get stuck in generating a pattern. It looks like train schematics, looks like a subway map. Yeah, those are great comments. All right, so I'm going to move on, but this is absolutely beautiful work. Thank you so much for sharing this. I wanted to finish though, but I'm going to move on. I'll run this more on my own. Oh, it's also probably running slow because I've got all these things running in the background. Okay. We are now optimized performance. Oh, fascinating. Okay, so it looks like what we're going to get with this one is not a new design, but optimized performance. And let's see what we can learn from it. So this is also a fork. Revamp the imperative for loops for higher order functional declarative version. Optimize several unoptimal loops. And the biggest optimization is implementing updates just for proliferating cells. Also added the possibility to declare non-square rectangular canvas. Okay. All right, so let's look also. Original version computed array of valid options for every cell in every loop. This is not optimal because the majority of cells don't change. The majority doesn't change. Rules are set in a way that only cells which are adjacent to the collapsed cells is proliferating, and therefore we are tracking the array of such proliferation cells and run entropy reduction only on those cells. This increases performance a lot and allows computing much larger grids. Well, here we go. Natya codes. Oh, wonderful. Are you glitchy? I'm confused about which, did I look at yours or I'm not? So I'm sorry about that. I'm kind of trying to keep one eye on the chat, but I'm not matching not your YouTube name with a GitHub name. So let me know if I've looked at yours already or not. So let's try running this. First of all, I would love to look at the commits. So, okay, so first, I need to get better at using some of these nice features of JavaScript, like the spread operator. We can see here, this is for calculating a rectangular grid. That's super helpful. Again, this is just using a higher order function. By the way, my understanding is that the higher order functions are really great, can be really great for sort of code being concise, but don't necessarily optimize the speed of anything. And in fact, are often slower than just a sort of raw for loop. But I haven't done any deep dive into this. Okay, these are all just changing but this I think is the sort of more significant change, right? This is where I'm drawing everything. What is this doing? This is just filtering things that are collapsed and then drawing those image. So this is just the same, but it's kind of like saying, draw all the collapsed ones, draw all the non-collapsed ones. And then, I have to think about this more. I'm not fully understanding why this third one is here, because this seems to me like it would cover everything. So I'm not entirely clear what this third one is. But that's, I'll come back to that. I'll have to look at that later. I wanted to sort of look at, so this is looking for the minimum entropy. This is what okay. Traversing the whole array every loop is not optimal. In fact, proliferation is possible only in some cells. Non-collapsed cells directly adjacent to collapsed cells. That makes sense. So start with all, So this is a really interesting optimization. I understand now. If we go back and look at my original code, what I'm doing is looking at every cell in the grid and calculating what are the possible states it could be, which tiles could fit here. But what this is proposing, and that seems correct to me, I have no reason to believe it's not, is I only need to do that analysis for cells that are adjacent to collapsed cells and that aren't collapsed themselves, presumably. And so by creating a separate list of cells that need to be checked, I only need to work through that shorter amount. And then that's what's happening through all of this. I have no idea what this is doing. I have to investigate what a JavaScript set is. Simon is offering some interesting comments saying that there is maybe an issue with this in that the recursive entropy reduction is never gotten around to. So I would imagine there's a way of doing this with also the recursive entropy reduction, that there's like a middle ground there. But this is too much for me to cover right now. So let's just keep looking through this. But this is fascinating. Okay, so now I've looked through all the changes. Let's try running it. And let's sort of put the pedal to the metal, if you will. I'm getting a little... Okay, so now... all right, so I'm just going to rename this. Whoops. So I'm going to put these both in here. Now we're going to look at this one. And let's run them side by side. So let's see what's running here. Let's close this. So this is my wave function collapse. My original wave function collapse is running at, oh, hi from China. Thank you, Frog Stud. Very kind of you. Is running at port 8081. Whoops. And the optimized version is running at 8082. So let's go. Sorry, this is tricky to manage this because they're all called wave function collapse. So this is mine. And I'm going to just set the same. So let's set them both to 600 by 600 and a dimension of 30. Okay? So this is mine is now set to that. And then this is the showcase one. Let's also set it to 600, whoops, 600 by 600. What is going on here? By 600 and 30. Let's just make sure this looks like the right changed code, right? No. This does not look like the... No, it is, because it's got... No, that's me, I did that. Wait a second. How can I tell where I am? All right, I need to just rename it. Hold on. This is the one I'm looking for. Let's call it optimized. Sorry, I know you can't see that. So I'm renaming this one wave function collapse optimized so I can actually tell what's going on because I can't tell right now. And let's go to Visual Studio Code. Sorry that I have so many things open here. Let's close this Python one. I'm going to close this one. Close this one. So now let's open the code for this one. We can see I'm the optimized one with dimensions 30, 600 by 600. This is strange. Did I not clone the right one? I think I didn't clone the right one. By the way, so git remote. Oh yeah, so I totally just messed up. I don't know if the chat is telling me this already. And Whale AI is explaining what the set is. Hold on, I've totally screwed this up. So thanks you for everybody's patience here. We're going to the optimized performance. And let me make sure I'm getting the correct one, which I can see here is V Balco. And then I'm going to rename that to optimized. I'm going to look at that in Visual Studio Code. Okay. So we're going to change it to 30 by 30. I know I'm in the right one now. And calculate cell size. I'm just going to have to assume that this is going to work correctly. 30 by 30. And let's close out. This is mine. I'm just closing out all these extra tabs. So I've got mine and I've got optimized. Optimized is running on port 8081. And mine is running on 8082. So let's take a look at mine first. So we can see the speed at which this is running. We can get a kind of sense of it. And let me do a force refresh just to be sure. Here, okay. All right, now, I don't know why that, let me pause that one. And let's go look at 8081. Oh, look at that. Yeah, so this is way faster. So definitely a major optimization. And I'm pretty sure this is the same. Looks like it's the same dimensions. I also love how there's something marking what needs to be analyzed. And yeah. This is great. So thank you for this. I'm going to have to dive deeper into this. I would definitely, I don't know if vBalco, if you're watching right now, I would certainly accept pull requests with some of these changes. I might go a little easy on the higher order array functions, but pull requesting this sort of this like basic optimization, I think would be great. The original code will always stand in the P5 web editor version. All right, so I've got two more to look at before I start to look a little bit more at entropy. And let's look at, Natia codes. Natia codes, did I get yours? Did I get yours? Let's look at GabRZs. So first of all, this is called Pretty Bad North. So if you're not familiar with Bad North is a game, I believe, made by Oscar Stahlberg. It uses wave function collapse to create these 3D scenes. I would love to say more about it. I'm not an expert on it at all. It's definitely one of the things I came across in my research about the wave function collapse algorithm. Townscaper, I think, is the sort of newer. I don't know what the relationship between Bad North and Townscaper is, but Townscaper is certainly, let's see. This is a great video to watch, which you can sort of see wave function collapse in action in a 3D world with incredible animation and visual design elements, like way beyond anything that I've gotten close to doing. And so it looks like what we have here. I'm closing all these tabs. And let's go to the code version from GabRZ. A basic 3D implementation of a scene. Nope. So Natia codes, where do I find yours? Is it somewhere like, is it on Twitter? Is it on a GitHub issue? Was it merged but not showing up? So let me know where I can find yours, Natia codes. So this is really nice to see. And I'm sorry that I'm running out of steam a little bit here towards the end of this stream and maybe not having as much mental fortitude to comment on some of these ones I'm getting to later. This is one of the things I really wanted to discuss today. I guess there's lots more follow-up streams I could do about wave function collapse, but a weighting system, I did not, and this also relates to the proper calculation of entropy, in particular Shannon entropy. But to sorry, I just got a little lightheaded there. To think of the possibility of a given image showing up in a tile. Let's say I have 10 possible images that maybe they don't have equal probability. So thinking about the sort of weighted probability of a given, like if we're creating a landscape, like maybe water is more likely than land, which is more likely than mountain or something like that. So, and we can see here that there's a wonderful discussion of a sort of set of to-dos. I'm just always curious to see if I can peek into, this looks very similar to what I did. Everybody is updating and using the spread operator. The tile class looks very similar. I'm just trying to understand where the 3D-ness is and where the rules are defined. Oh, here they are. Oh, I'm looking in the wrong code base. Where am I looking? How did I get there? That's so weird. A cell. No, whoops. Oh my goodness, look at me. The interface, it's looking, I've totally tricked myself. I'm like looking at this and thinking this is a way for me to browse the code. That's Visual Studio Code in the background. Here are the code. Sorry about that, everyone. So we can look at grid. We can see that there are slots. This term of slot, there is sorting and looking at the entropy, picking a new option. I'm not going to be able to, I was just sort of hoping to see if I could find the rules. Looks like there is this idea of sockets in a mesh. So in 3D, it's actually much more complex to connect all these neighbors. So it looks like there's probably a different way of looking at this. But I suppose we could find grid.draw. I'm sort of curious to see. Look at the draw function. I'm just curious to see what slot.draw. I just wanted to see what are the sort of like native shapes that are being drawn. And it's drawing a particular model. So each one of these cells is like a polygonal model. That makes sense. And I can restart it. What if I want to lower the speed quite a bit? Yeah, so this is great. I encourage you to continue this. I would love to see more examples. Not your code, submitted it on the site. Okay, so we are now done with the ones that have shown up here. And I'm just going to explain to you something that's going on the website. And so I'm first going to go here into issues. So there's an issue happening where not all of the showcase projects are actually showing up on the website, and I hope to have this resolved next week sometime. Now, why is this occurring? So what's happening is, for whatever reason, the Netlify / Gatsby build process does a lot of caching to speed up the build of the website. And I'm not sure why, but the passenger showcase doesn't always update. And I was able to get it to update by running clear cache and deploy site. You can see that it took it took 67 minutes to build the site. That's not really a sustainable amount of time. So I need to figure out how to, and we had a little bit of discussion about this here, but I need to figure out ways to optimize the build and or not be able to recognize when the passenger showcase has been updated and not have that cached. My suspicion is, and I've not done any actual analysis, that my guess is somehow if I haven't made any changes to this page, like the passenger showcase is stored in separate JSON files in the engine of the site. So my suspicion is if I didn't change the language of the description or change a time code, that the page doesn't rebuild. It just uses the cached page, even if there are new showcase projects. This would be something that's happening in Gatsby, I have not investigated to know what this is true, but it's the only thing I can think of. Because why is it that the showcase sometimes doesn't update even when we've merged a pull request? So if anybody knows or wants to help resolve that, Rune Madsen, who's one of the designers from DSI who built and designed the site, is going to be investigating this more next week. We have scheduled some time to look at this together, but if you have any ideas, please let me know. But good news is I can find, so Nacha codes, I don't see a pull request here, but I'm going to go look at, unless it was closed already, I'm going to look at this one from Radek. So Rodak 123. So I'm going to have to manually go and look at your project. Train, track, car, roads, and tunnels in processing Java. So one thing that I commented on, this looks like you uploaded as the sample image, one tile. So first of all, A+ for uploading a small image. Like the preview images shouldn't be big images because it will cause the website build to take forever because it's got to resize them all. But this is too small, I think. So usually I think we want like a 400 by 400 or 800 by 800 image we're looking for. But I'm just going to go direct to your URL. Try this.showcaseprojects.update. I don't know if that's a real comment or not. And let's clone this one. And thankfully we've got a different name. And this looks like it is a processing sketch. Fantastic. So we're going to open this up in processing. I'm trying to keep this. Somebody please help me find Natya Code's project so we can look at it before I go. I don't have a lot of time here. Oh, wow. So this I've always been wondering about. So I really want to add this. It looks like, so first of all, this is fantastic. And I love, of course, it's like train tracks. I mean, this is amazing. Oh, I love it. Train whistle for this one. So one of the things I love about this is it looks like visually it's overlaying all of the possibilities with alpha transparency. And I love the way that looks and kind of gives you a preview of what's to generate. So I really want to add that to mine. Thank you so much for adding that to this. I just love it so much. 800 by 800, but it failed. Yeah, Rodak, there are some issues. It looks like you have the member icon. Please message me in Discord and let's get a thread going in Discord to try to help you sort this out so we can get this on the website. But this is just absolutely wonderful. And I'm sorry that I'm low on time here to look at this in more detail. But I can see the amount of effort and time. Oh, look at all of these tiles. There's so many. Where did you get these? Did you design them yourself? Is this from some other example? It's just wonderful. I'm gonna run this while I'm talking. Okay, last call. Wow, I have this list of things I wanted to go over and do today, which I'm not getting to clearly. Lego PC game just like this. Last call, Natya Codes. Let's see if we can make a guess here. Natya Codes. Nope. YouTube. Is it on YouTube? About Studious Gamer. Okay, let's try this. Whoa, okay. We're looking. You drew them. Wave function collapse. Oh, we've got another. Wow, amazing. So first of all, wonderful job updating this. This looks like it's, I really want to quickly run this. So let's quickly run this. I'm going to throw caution to the wind here. And, oh, did I lose my Python one? Where is it? No. Is it this one? Yes. So I just wanted to activate that. I'm just going to use the same, throwing caution to the wind. And I'm going to use the same virtual environment, which is, oh, whoops. Oh, it's also called wave function collapse. Okay, so now let's try doing this. We're getting pillow and pie game. So these, I assume, are for the graphics engine. Okay, and we're just going to run main.py. Oh, amazing. Oh, look how fast this runs. So it's great to see how fast this runs in Python. Oh, beautiful job. So this is really cool that we have both a Python script that just generates the image with no visual, and now using Pygame, I assume, is what's this engine for drawing it. So wonderful work, Natya Codes. I'm sorry that I'm running out of time here. I would love to review this further. I encourage everyone to check out and run this themselves. Looks like I can go into a different directory to export an image, and then maybe there are ways to change the tiles, R to restart. Look at that, fantastic, great work. I love seeing these. I'd be curious to hear more. Let's make sure we can get this on the website as well. All right, so this is a little bit unorthodox here, but one of the things I really wanted to talk about on today's stream was entropy. And here we are. I want to, let's take the 10 minutes here and let's cover the topic of entropy. And who do I have to help me cover the topic of entropy but none other than the sponsor, pretty much the main sponsor of the Coding Train, which is Brilliant. So if you like the Coding Train, if you like learning and watching my videos, hopefully you're inspired by them. Maybe they're entertaining for you. Maybe you learn something. But the best way to learn, I really believe, is by doing it yourself. So maybe my videos encourage you. Hey, if you want to bring me a kitten, you can. Maybe my videos, we're fostering some kittens. I thought maybe I would. My videos inspire you to learn and try something yourself. But Brilliant is a website. There's an app, tons of courses with interactive lessons, and so many ways you can learn. So whenever I'm trying to learn a topic, I immediately go to the Brilliant website. So you can sign up for free. Please do so after the stream today. If you haven't, sign up at brilliant.org/coding train for free. It lets them know that you found Brilliant through the Coding Train. Yay, that's a nice thing for me, for you. Of course, if you are interested and want to unlock all of the courses, I'm going to show you what you can get with a premium subscription. And through that link, the first 200 people to use it will get 20% off. So let's go back and actually look at the Brilliant website. And I'm just going to show you here under courses, all the different courses. So first of all, I want to just highlight this beautiful geometry course, because if you like making pretty pictures with math, with code, you're going to get so many ideas from here. So, I've made, I think I'm on Coding Challenge 173 now. I'm always looking for more ideas and more things that I could try as a coding challenge. This is a literal treasure trove of stuff. So I really encourage you to poke around the Brilliant website if you're looking for ideas of things you can try with code. What I want to look for is information theory. Oh, I'm so likely to I'm literally extremely likely, the fact that I'm recommending Brilliant on a live stream. I mean, it's a sponsor. I'm paid to do so, but I would recommend it regardless. Information theory. So let's go here, knowledge and uncertainty. So learn the math behind uncertainty. Can you put a number on how much you don't know? Sure you can. When you learn something new, how should it change your beliefs about how the world works? This course gives you tools for managing uncertainty and interpreting information. You'll learn cutting-edge mathematics like information theory. So the concept of entropy, I want to come back and I'll have to revisit this in a future live stream or video to get a little deeper into information theory and entropy. This course really has a wonderful set of interactive quizzes. So let's get started working through this for just a few minutes. Let's work together and see what this course is like. It is said that we live in an information age. Indeed, information is a powerful force that shapes our world and the range of human experience. But what does it mean to have information? Is it something we can have more or less of? How do we go about obtaining it? So the answer to this question leads to three closely related ideas. So information theory, I'm Bayesian. Oh, I want to do so many videos on Bayesian. I mean, I had a little bit in the Monty Hall problem about Bayesian inference, but I want to do Bayesian text classification, spam detection sometime. Let's go on. So we're going to start this journey with Alice. She's trying to figure out how to ask efficient questions that obtain the most information possible. Oh, this is so good. Guess who, by the way? Minesweeper was a lot of people commented on my wave function class video. Why didn't you use Minesweeper? Which is a great game also to demonstrate information theory and entropy. I was watching a Khan Academy video about information theory that was talking about thinking about this idea of bits, how much you can measure information in terms of bits, and a bit being like how many yes or no questions do you need to ask, flip a coin. So let's keep going through this. A terrible crime has been committed. A rare and precious diamond was stolen. Here are the main suspects. Alice needs to find the criminal by asking a few yes or no questions as possible. All right, let's see if we can do this. Suppose Alice's strategy is to go through the suspects one by one by asking, was it Audrey, was it Bill? This is so good. This is such a great way to, I don't know, I have to ask Brilliant if I can use this in a video, if I make a video more about entropy. Often so like entropy can be measured, it's almost like a measurement of surprise. And I can see where this is leading to, because one of the ways to think about entropy and information theory is to get to the right answer, how many yes/no questions do you need to ask? So one way of doing this is just asking individually, is it this person? Is it this person? Is it this person? 4, that would be 16. So I guess I only need to ask 15 questions because by the time you get to 15, the last question, you'd be getting the right answer. Incorrect. 8. Oh, 8! Oh, my brain, right? Because 8, wait, what did I, show the explanation here. I think I'm one by one. Oh, on average. I always missed this. Such an important point. See how I supposedly have some level of expertise in this stuff. And I mean, I have been streaming for 2 hours and still getting over like being sick like a week ago, and cut me some slack here. But of course, the whole point of this is not I was thinking about, this is very similar to big O notation. I was thinking about what is the maximum number of questions you would have to ask. But this is on average. I could get lucky and get it on the first try, or I could have to ask all of them. So on average, since they all have an equal likelihood, the average number of questions is 7.5, because 15 is really the right answer. Okay, back to the problem. Okay, let's keep going. See, this is what I love about Brilliant. It's giving me these interactive lessons with questions, and then it's not the worst case. And then if you get it wrong, there's a wonderful, like, that's the way to learn. Like, I'm not going to forget that next time because I got it wrong. So I'm kind of out of time here. I would love to go through more of this. What I wanted to do is I just want to briefly look at here, like the thing that I want to skip to. So the bit is the perfect unit for measuring your uncertainty. A bit relates to this idea of a single yes or no question. And by the way, what this is leading to is we could start to design our questions in different ways. Like, is the person who committed the crime, were they wearing glasses? And that might eliminate a certain number, and we can start to measure the uncertainty, the bits, the amount of surprise we have in terms of getting the right answer in more ways. And then we can see this formula. Oh, that formula right there. This is what I wanted to dive deeper into. And I should really use this formula in the wave function collapse algorithm but I wanted to mention that here. So I would encourage you, if you want to learn more about information theory and entropy, this is now using the flipping coins, to check out Brilliant. It's a wonderful, I'm so grateful to Brilliant for sponsoring the coding train. You didn't see it here, but a lot of the lessons have a lot of interactivity where you get to drag and drop sliders or rearrange puzzle pieces. They're really fun to play with. Just doing that alone, but also like gives you ideas of interactive things you could create. It'd actually be interesting to think about making like a coding train course on Brilliant or something someday. I have to consider that. So anyway, brilliant.org/coding train. You can sign up for free. Let them know that you found it. If you want to unlock all the courses and all of their features, you can get 20% off a premium subscription. It's also a great gift idea. Somebody's birthday, I don't know, somebody's birthday is coming up. You can gift them a premium subscription. You know, if you don't know what to get somebody, they have all the things. You don't want to buy more plastic. But they love learning. They love math and science. It's a great gift. All right. Please check out Brilliant. Thank you for the sponsorship. One last shout out before I go, which I meant to cover earlier, but I want to just quickly click over to the references here. So this is the GitHub. Oops, you're not seeing this. Oh, and thank you, Tony K, for joining. Very kind of you. Make sure you sync your Discord account. So one thing I wanted to mention that I would really encourage you to do a deep dive into, in particular if you're interested in the tiled model, is to go and look through the in the original wave function collapse repo, which is what I based my coding challenge off of, to go to the credits and wait, hold on. I'm looking for, maybe I'm in the wrong. Used work. Sorry. To go to the used work, you should definitely look at all of these references. I didn't do I probably should have done a better job of citing the sources for wave function collapse as I was citing wave function collapse. But in particular, I wanted to highlight model synthesis, which is a particular algorithm that Merrell did a PhD thesis about. This is the thesis in 2009, and it's really, really interesting, highly detailed, long read about a technique for essentially creating these tiled textures using, and again, I haven't had the time to read this through in detail, but a different heuristic, a different methodology, maybe a way of selecting the tiles that might have some advantages. Maybe there's some pros and some cons between model synthesis, but the two are quite similar in interesting ways. And I would encourage you to check out this original work. I would say the overlapping model is really where wave function collapse takes this idea of model synthesis and placing tiles next to each other and really runs with it in this really amazing direction that I hope to get to I plan to in a future live stream / coding challenge. Woo! So that's all I've got for you today. Thank you again. I didn't get to David Snyder. I didn't get to your correction. So there's a lot of things. I made a whole Google Slides presentation. Unfortunately, I just am like out of time. But while we're here, I would encourage you to check out and help me help contribute. Oh, you're not seeing this. Help contribute to this README that's in the wave function collapse repo, because this is my plan. So these are some things that I want to do and look at in the future work. There was also like a really bizarre thing that happened to me with property names, and David Snyder submitted this excellent explanation and correction, which I wanted to go over today, but obviously I've run out of time. But if you have ideas for how to approach the overlapping model, things that I should do, next steps in refactoring, optimization, corrections from the video, this is my running list of things that I want to cover and do in future live streams and video. All right, everybody, I'm sorry that I have to go. I appreciate you all so much. Don't forget, this Saturday, less than 48 hours from now, I will be right here with Dr. Christian Hubicki from Florida State University, who runs a robotics lab there, to talk about robot controllers. And this, I'm hoping, is going to launch a whole new series eventually of some coding challenges on the coding train for simulating robot controllers. So that will be happening on Saturday at 11 a.m. I've got to go. I'm already a minute late to my next meeting. No kittens today. Sorry, everybody. Next time, I'll bring you a kitten. Maybe as I'm playing the outro song, if I can manage it, I'll show you a kitten. Thanks, everybody. I will see you next time on the coding train.